Good morning, students. Today we will be discussing our next session on circles. This is in continuation of the previous class, and all the previous classes lectures are available in that online test platform at cornerclasses.com, as well as it is available in YouTube. Now, today what we are going to discuss is that the first we'll discuss about the two circles, about their relative position, and then we'll discuss about the tangent to the circle at a certain point. Now, before I proceed further, I just like to confirm from some of you that you are able to hear my voice very clearly and able
Yes,
to
sir.
view the screen properly.
Yes, sir.
Okay, great. Thanks for the confirmation. Now, when you are discussing about circle and circle, that means there are two circles, right? So let us have the equation of the two circles, something like this. Suppose the first circle is having equation, the general equation of circle, the way we know that x square plus y square plus 2gx plus 2fy plus c equal to 0. Suppose we have the first circle is something like that, x square plus y square plus 2gx plus 2fy plus c is equal to 0. And the second circle, that is s dash, if we name that circle as s dash, so its equation will be x square plus y square plus 2g dash x plus 2f dash y plus c dash is equal to 0. Correct? Now, think about what would be the different positions of the circle. Relative position. I wanted to mean by relative position. So if you look into it, dear students, so you will find these are the 5 relative positions you can think of. Correct? So as you see in the screen. Okay. So let's assume the first circle is having the center at C, and the second circle is having the center as C dash. Then you'll be able to get any of these 5 situations between two circles if you represent them in a graphical representation. So this is the graphical representation, but just by means of algebra, how you can conclude that what is the position between these two circles among these 5. If you look into this, the first one, that if you look into the first case, that how it looks like, it looks like these two circles are actually intersect. Correct? So the first one is that they are intersect. If you look into it, they are actually intersect. Or I can write down here. So the first case is actually intersect. Now, when these two circles are intersecting each other, then think about what we are going to find. We are going to find the distance between the centers, that is C dash, and how they are related with the corresponding radii. So we are assuming that the center of these two circles at the point C and C dash. So if I use a different color, so we can say is that this circle having center at C and a radius R, and this circle has center at C dash and radius, length of the radius is R dash. So now when they are intersecting each other, then definitely the inequation is going to hold true, that the non-negative difference of R and R dash, so that means non-negative difference between R and R dash means R minus R dash mod value, that should be c dash, and that should be less than r plus r dash. Correct or not? If these two circles are intersect each other, then the distance between the center will be definitely less than the sum of their radii, and definitely greater than the non-negative difference of their radii. Now the next one is that if you look into the next case is that these two circles are touched externally. So if I use a different color pen, so here it is touch externally. Now as they are touching externally, so obviously one thing is going to be true, the distance between the centers will be equal to the sum of their radii. Correct? Now the third case, what is coming is that these two circles are touch internally, right? So let me use a different color here. So they are touch internally. If they touch internally, then what is the relationship what we are going to get, dear students? That C dash should be the difference between their radii. So we will take the non-negative difference because C dash is positive, the distance between 2 points. So C dash should be mod of r minus r dash. And here, student, one thing you should notice is that between r and r dash, we do not know which one is actually more. In this symbolic representation, we see that r dash is less than r, but it may not be the case. So when we take r minus r dash or r dash minus r, whatever, we will take the non-negative value. That is why I wrote it as mod. Now let's come to the case number 4. In this case, we see that these two circles are outside to each other. Correct? So when they are outside to each other, dear students, so outside, so let me write it down. Outside to each other. If they are outside to each other, then the distance between their centers should definitely greater than the sum of their radii, so that is greater than r plus r dash. And the fifth case, as you see, dear students, that one circle is contained in the other. Okay, one circle is contained in the other. So let me use a different color pen. So one circle is contained in the other. So what will be the condition here? The distance between their centers should be less than the mod of r minus r dash. Correct? So these are the 5 different cases, dear students. So now what I'm going to do is that I'm going to just write this in the tabular form so that you can memorize it well, and then we'll solve one representative problem. So what we understood is that two circles will intersect each other. Let me write down this one, the step by step. The two circles will intersect if mod of r minus r dash is less than c dash is less than r plus r dash. Two circles touch externally if c dash is equal to r plus r dash. The two circles touch externally if c dash is equal to mod of r minus r dash. Two circles, are outside to each other if c dash is greater than r plus r dash. And one circle is contained in the other if c dash is less than r minus r dash. Now, as we understood this thing, dear students, that let us now start working on a problem. And I will appreciate that you also, open your notebook and start working on this problem as well along with me. Okay. And here is the question. Question is, let me first place it. Prove that the circle x square plus y square plus 2ax plus c equal to 0 and x square plus y square plus 2by plus c square equal to 0 touch each other if 1 by a square plus 1 by b square is equal to 1 by c square. Interestingly, dear students, here it is, given the question as the touch each other. It is not very specifically mentioned whether they touch externally or they touch internally. That means any of these two cases are possible if I give a visual representation. Correct. And how we can make use of this and solve this problem, isn't it? I hope you understood any of these two cases is possible. So now let us look into the first one. So first one is that what equation we can look into is that x square plus y square plus 2ax plus c square equal to 0. Now if we assume that the radius of this circle as r1 and center is at the point A. So suppose center, let's assume that center of this circle is at the point A. Then what will be the coordinate of center? Then minus a comma 0. Correct, na? And what will be the radius? Radius, if we assume as r1, that is equal to square root of a square minus c square. Okay, from where it is coming. Very quickly I can tell you, if the equation of the circle is x square plus y square plus 2gx plus 2fy plus c equal to 0, then the center is at the point minus g comma minus f and radius is equal to square root of g square plus f square minus c. Now let's look into the second circle. Second circle equation is given at there, students, is that x square plus y square plus 2by plus c square is equal to 0. So what is the center? Coordinate of the center, if we assume it is represented by the point B. Okay. Or one thing we can do is that as we have given it as C and C dash, so let me write it down as C and C dash to make, exactly like whatever is mentioned in the question. So let's assume this is C and this center C dash will have, radii is coordinate of the center should be 0 comma minus b, and the radius, if we assume the radius as r2, then the radius r2 should be equal to square root of b square minus c square. Now we do not know whether these two circles are touches externally or internally, so you should take both the cases. Now if they are touching externally, then what is going to happen? Then C1, C2, C dash should be equal to R1 plus R2. Okay, let's do one thing, dear students. So instead of R1 and R2, let's take R and R dash so that we can make it, exact in the manner of and that center whatever we have taken. So R and dash. So C dash should be equal to R plus R dash if they touch externally, means this case. And if they touch internally, then what will going to happen, dear students? Or we will get C dash is equal to mod of R minus R dash. Correct? So this is the case. Now we can combine these two cases. How? Let's see. So C dash is equal to R plus R dash. That means C dash square is equal to R plus R dash square, or C dash square is equal to mod of R1 minus R dash. That means C dash square should be equal to what? R minus R dash square. Correct? Now if these two circles are touching each other, then we need to touching each other both internally and externally. That means we can club these two together. If we club these together, then what we are going to get it, dear students, is that C dash square is equal to, so what we are going to do is that we are merging these two together. Then what we are going to get? We are going to get C dash square is equal to R plus minus R dash square. Correct or not? So if this is the case, then let's expand it. So that implies what? C dash square is equal to, is nothing but the distance between the two centers, that is equal to square root of a square plus b square whole square, that is a square plus b square. C dash square will be a square plus b square is equal to r square plus minus 2r into r dash plus r dash square. Correct? Now what we are going to get from here is that let's find what is r dash square. R dash square is equal to we know is that it is a square minus c square. Let's have a look into it. So c dash, you understood that why it is a square plus b square, and here you see, so let's write a square plus b square is equal to r square is equal to a square minus c square plus minus 2 into r dash, the 2 into square root of a square minus c square into square root of b square minus c square plus r dash square. R dash square is what? B square minus c square. Correct, not dear students? So from here, what we get that a square in the right hand side, a square in the left hand side got cancelled, b square in the right hand side, b square in the left hand side is cancelled. So in the right hand side, there are 2 minus c square, we took it left hand side, so it becomes 2c square is equal to plus minus 2 into square root of a square minus c square into b square minus c square. Correct? Now 2 got cancelled and we make further square. That means c power 4. Why you make further square? To get rid of this plus minus. Because plus whole square is plus, minus whole square is also plus. So that is why we make square of both the sides and we get a square minus c square into b square minus c square. So this implies c to the power 4 is equal to a square b square minus a square c square minus b square c square plus c to the power 4. C to the power 4 in the right hand side will get cancelled with the c to the power 4 in the left hand side. So then, dear students, what we are going to get? A square c square plus b square c square is equal to a square b square. Now what we are going to do? We are going to divide both sides by a square b square c square. So then what we are going to get? 1 by b square plus 1 by a square is equal to 1 by c square. Here we are writing by dividing both sides by a square b square c square. So, and obviously a square b square c square is not equal to 0, otherwise the question will not have been make any sense. And we are able to prove it. Correct, dear students? I hope it is pretty clear to you, and we understood about the that relative position between two circles. Now, dear students, we are going to discuss next topic is called the tangent to a circle at a particular point, and let's see that how we can do it and how we can remember all these things in a pretty effective manner. So the point of discussion is that equation of tangents to the circle at the point p x1 comma y1. Okay, so and let me first bring the topic to a new page. So here I use the word tangents to the circle. That means depending on the different type of equation of circle, you will get different type of equation. Okay. Now, if you recall that what are the different flavor or different versions of circle we got so far? One is that equation of the circle with center at origin and having radius r. What is that? X square plus y square equal to r square. correct? Then we know the equation of a circle with center at the point h comma k and having radius r. What is the equation? It is x minus h whole square plus y minus k whole square equal to r square. Then you know that the general equation of a circle, what is that? X square plus y square plus 2gx plus 2fy plus c equal to 0. So generally we know these three different versions of equation of a circle. Now, depending on what is the kind of equation is given to us, we can actually find the equation of the tangent to that circle at the point x1 comma y1. Okay, so how we can find it out? Let p x1 comma y1 be a point lying on the circle. Then the equation of the tangent in different forms of the circle is actually obtained from the following table. Okay, dear students, I hope all of you are able to view it. So if you look into it, that we have a circle. So if I give symbolic representation, so it should be something like this. That suppose the circle is something like this. Okay, and what we are going to find is that we are going to find the equation of the tangent. Suppose the tangent I am drawing in blue line. So this is the tangent. Okay, now if you look into it, dear students, that if the equation of the circle, so this is a circle with center at the point origin, if this is the case, then the equation of the tangent will be this, x1. If the equation of the circle is x square plus y square equal to r square, then the equation of the tangent will be x1 plus y1 minus r square equal to 0. Now, if you look into the second case, where the equation of the circle is given in the form of x minus h whole square plus y minus k whole square equal to r square. That means what? It is a circle with center at the point h comma k and having radius r square. If this is the case, then what will be the equation of the tangent? Equation of the tangent will be x minus h into x1 minus h plus y minus k into y1 minus k minus r square equal to 0. If you look into it here, dear students, is that the pattern, there is a pattern of finding the equation of the tangent at x1 y1. Now in the third case, if the equation of the circle is given in the general form, that is x square plus y square plus 2gx plus 2fy plus c equal to 0, then the equation of the tangent to that circle at the point x1 comma y1 is x square plus xx1 plus yy1 plus g into x plus x1 plus f into y plus y1 plus c is equal to 0. Correct? So these are the three different versions of circle and their corresponding equation of the tangent at the point x1 comma y1. Remember one thing, dear students, very important. Sometimes it actually get confused to some students. Whatever you see in the second column, that is the equation of a tangent. What is a tangent? Tangent is nothing but a straight line. So all these straight lines, that is xx1 plus yy1 minus r square equal to 0, or x minus h into x1 minus x minus h into x1 minus h plus y minus k into y1 minus k minus r square equal to 0, or xx1 plus yy1 plus g into x plus x1 plus f into y plus y1 plus c equal to 0. All these are representing the equation of a straight line passing through x1 comma y1. Correct? Now that will become a tangent if that point x1 comma y1 is lying on that circle. Let us understand by means of an example. For example, consider the circle. Let us take a circle. For example, is the equation of the circle is something like this: x square plus y square minus 4 equal to 0. X square plus y square minus 4 equal to 0. And the question is, the point is given as the point P. Suppose this is the point P, what we define, that x1 comma y1. The point is given as 1 comma 1. Okay. And suppose the question has been asked to you, hey, what is the equation of the tangent to the circle at the point 1 comma 1? I will show you, dear students, that question doesn't make sense. But generally what students make a mistake is that, oh, it is in the form of x square plus y square. X square plus y square minus 4 equal to 0 means what? That means x square plus y square equal to 2 square. So what is the equation of the tangent? Generally student makes a mistake is that equation of the tangent is that x into x1 is 1 plus y into y1 is 1 minus r square means minus 4 is equal to 0. That implies the equation of the tangent become x plus y minus 4 equal to 0. But that is not true. Why? Because that point 1 comma 1 is not on the circle. It is actually inside the circle. How to find it out, dear students, whether it is inside or outside? So we will find the value of this expression. In fact, we want to find the value of that expression x square plus y square minus 4 when x is equal to 1 and y is equal to 1. What is the value you are getting? 1 square plus 1 square minus 4. That means 1 plus 1 minus 4. That is equal to minus 2, which is less than 0. That means the point 1 comma 1 is inside the circle. How it is possible to draw a tangent to a circle which is a point which is inside the circle? Not possible. To draw a tangent to a circle, always the point has to be on the circle. But we found that straight line. This is a very, this straight line is passing through, this straight line, if you look into it, that this particular straight line, if you look into it, does not represent the equation of the tangent. Okay, but it always makes sure that whether the point is on the tangent or not. That you need to make sure first. Okay, so that is the very important point. Okay, now we are going to solve a problem which is very interesting problem. I'm going to solve and related to the equation of the tangent. Okay. Okay, let me first give you the problem first. So one point what I'd like to mention before I go for this, the next question is that whatever you see in the straight line equation in the second column, that is x1 plus y1 minus r square equal to 0, or x minus h into x1 minus h plus y minus k y1 minus k minus r square equal to 0, or x1 plus y1 plus g into x plus x1 plus f into y plus y1 plus c equal to 0. All these are represent the equation of a line. Now that line not necessarily means that it has to be a tangent. That line can only be a tangent if the point is on the corresponding circle. Okay, it doesn't mean that that line has to go through that point x1 comma y1, which I said in one of our statement few minutes back. That is not correct statement. That is wrong. That I repeat, whatever the straight line what you see in that in a second column, that represents a straight line. Now that straight line will qualify to be a tangent to the circle if the point is on the circle. That means the point has to be on the circle. Here we see one example that in this example, as you see, that where we observe that point 1 comma 1 is not at all on the circle. It is inside the circle. But just blindly we should not write the equation of the tangent to the circle as x plus y minus 4 equal to 0. And before I proceed further, I can show you the the relevant notes so that you can make it you can read it and make more sense out of it. And it says is that note that t equal to 0. T means the tangent. Okay, so all these things are represented as t symbolically. Okay, so t equal to 0, always represent a line where p x1 y1 lies on the circle or not. But t equal to 0 represent the equation of the tangent at p x1 comma y1. Okay, only when p lies on the circle. Okay, you look into it. So these all are represented at equation of the tangent is represented as t, and equation of the circle is represented by s generally. So this is a symbolic representation. Okay, and whatever the example I have done it here, it is actually explained by means of this statement. Okay, now dear students, I'm going to solve one interesting problem together, and I want all of you to work along with me. And let me first show you the question, and then followed by its solution. Look into this question. The question here is that the circle x square plus y square minus 4x minus 8y plus 16 equal to 0 rolls up the tangent at 2 plus root 3 comma 3 by 2 units. Assuming the x-axis as horizontal, find the equation of the circle in the new position. Let me first show you that the visual representation of this problem. Suppose this is x-axis, this is origin, and this is y-axis. Why I'm considering only the first quadrant? Because you see the point 2 plus root 3 comma 3 is in the first quadrant. Okay, so for the sake of simplicity, I'm taking only the first quadrant. Let me focus on the problem. Now, before that, let me explain you what is exactly asked, what is meant by this rolling over the tangent. Let me first explain you what is meant by that. So now let's revisit the question once more. As you see the diagram, the circle x square plus y square minus 4x minus 8y plus 16 equal to 0. This is the circle. And as we know, the moment the equation of the circle is x square plus y square minus 4x minus 8y plus 16 equal to 0. Always, dear students, whenever you get an equation of a circle like this, you can represent in the form of a generic one, x square plus y square plus 2gx plus 2 into minus 2 into x, as if g is minus 2 plus 2 into minus 4 into y, that is f is as if minus 4 plus 16 equal to 0. Now, what is the coordinate of the center? Coordinate of the center is at the point 2 comma 4. Coordinate of the center is at the 2 comma 4. Let's assume that center is at the point A. Now 2 plus root 3 comma 3 is a point P here. So that is the tangent. So what will be the tangent? You see, this is the equation of the tangent. So if you take this tangent as T, so this is the tangent. Okay, as you see in that line. Okay, now what happened is that circle, as if that in that line T dash there is a you can make it is a slanting line. Okay, and or you can think about that it is an inclined line. Okay, along that inclined line, the circle actually rolled up. Okay, it is rolled up and go for the 2 units. That means the distance between P and L is actually 2 units. Then what will be the, after rolling up, what will be the new position? That is the new position of the circle. New position of the circle. Now what we need to find is that we need to find the equation of this circle at this new position. Correct? So how to find it out, dear students? So first, what we need to approach is that first we need to find what is the equation of the tangent to the circle at the point 2 plus root 3 comma 3. Okay, So we write here is that equation of the tangent to the circle. So let me give this equation of the circle 1 to the circle 1 at the point P is 2 plus root 3 comma 3 is, if you recall that x, the tabular form, so it becomes 2 plus root 3 into x, correct, plus 3 into y minus 2 into x plus 2 plus root 3, correct, minus 4 into y plus 3 plus 16 is equal to 0, correct. Now if we simplify this thing, I'm not spending time on simplification, dear students. If you simplify, you will get something like this: root 3 into x minus y minus 2 root 3 is equal to 0. That is the equation of the tangent. That is the equation of the line T, as you see. Correct, now, dear students? Now, if the angle, if this straight line, that tangent T, that is which is expressed in the equation 2, makes an angle theta with the positive direction of x-axis, then what will be tan theta? That means if we extend that line like this, then what we can say is that if this is the angle theta, then what we are going to get tan theta? Tan theta is nothing but slope of the line 2, that is equal to root 3. If tan theta is equal to root 3, then, dear students, theta is equal to pi by 3. Correct or not? That is, or we can write in the degree measurement equal theta is equal to 60 degree. Now, A is the point 2, 4, and B is the point which is at a distance, 2 from A. AB is equal to 2 now. This AB length is equal to 2. So if you look into it, this AB length is nothing but 2 units. Correct? So then we need to go to the distance form of the straight line. So if A is the point having coordinate 2, 4, I'm just writing once more. A is the point having coordinate 2, 4. AB is equal to 2 units, and the inclination of the AB with the x-axis is theta. If tangent is having an inclination theta, then obviously that line AB is also should have inclination theta, na? Because the line segment joining the centers of the circles in the old position and new position, that is AB, should be always parallel to the tangent, that is T. So then the inclination of the line AB is theta. Then what you can find the equation coordinate of the point B is actually A plus r cos theta, means 2 plus 2 cos 60 degree, 2 cos 60 degree, and 4 plus 2 sine 60 degree, 2 sine 60 degree. Correct or not? That is the distance formula of the straight line. From there, if you want to recap, you can go through that particular video lecture available in the online platform as well as in YouTube. Okay. So from here, if we find it out, what we'll get, the coordinate of the point B is 2 plus cos 60 degree. Cos 60 degree is equal to 1 by 2. So that means 2 plus 1 is 3. 3, 4 plus root 3. Because sine 60 degree is equal to root 3 by 2. Now, we are going to find the equation of the circle having center at B and having a radius. We are already aware of what is the radius. The radius is 2 units because g square plus f square minus c. Correct? So center we found it out. We can also find it out what is the radius. Radius will remain the same now in both the old position and new position. G square is 4 plus f square is equal to 16 minus c minus 16, that is equal to 2 units. Correct, na, dear students? Got it? So then what we are going to find it out? So the equation of the circle at the new position is nothing but the equation of the circle with center at the point 3, 4 plus root 3, that is the point B, and having radius 2 units. So what will be the equation? X minus 3 whole square plus y minus 4 plus root 3 whole square is equal to 2 square. Correct or not, dear students? So now we just need to simplify. I am not spending time in simplification, dear students. So if you simplify, you will get something like this. So this implies x square plus y square minus 6x, x square plus y square minus 6x minus 2 into 4 plus root 3 into y plus 24 plus 24 plus 8 root 3 is equal to 0. Okay, dear students, so with this we are able to solve this particular question, right? So this is the equation of the circle in the new position. Okay, now what we are going to discuss, we are now going to discuss the equation of the tangent to a circle, at a in terms of the slope m. Okay, so equation of the tangent in terms of slope m. So let me take you to the next page and explain you in further. Okay. And that will be the last topic for today. So equation of the tangent in terms of the slope m. So let the slope of the tangent be equal to m. Then there are two tangents to the circle with having the same slope equal to m. What are those? Let us have a look into it. Okay. Let the slope of the tangent be equal to m. Then there are two tangents to the circle which have slope equal to m. Now it depends on the what is the equation of the circle. If the equation of the circle is of type x square plus y square equal to r square, then the equation of the tangent will be y equal to mx plus minus r into square root of 1 plus ms square. Okay. Now, if the equation of the circle is x minus h whole square plus y minus k whole square is equal to r square, then the equation of the tangent should be y minus k is equal to m into x minus h plus minus r into square root of 1 plus ms square. Correct, dear students? I hope you got it. Now, you may think, sir, how it is possible to have two tangents, okay, having the same slope m? Okay. Let us understand by means of a visual representation so that it will be amply clear. So suppose this is the circle. Okay, now in this circle, if I draw the straight line, the tangent in green color. So suppose the straight line, this one, is having slope m, that blue line what you see. Then we can this is having slope m. Now the question is that how it is possible to have another tangent having the same slope m? Not a big deal. So the other one I can draw in the green line, which is parallel to the the blue line. You see, this is another tangent having the same slope m. Both the green line and the blue line are tangents to the circle, but both are having slope m. Na? So in this way it is possible. And one more point, dear students, that you may say, sir, what about the general equation? Generally, you explain three flavors. Equation of a circle having center at origin, with radius r. Equation of a circle having center at the point h, k, and having radius r. But what about the equation of the generic equation of the circle, the general equation of the circle, that is x square plus y square plus 2gx plus 2fy plus c equal to 0. Dear students, if the equation of the circle is given in this general form, then we need to follow little steps. Okay, and here it is. The steps are like this, very simple steps, but we need to follow these steps. It is not a very straightforward tabular manner. That's why I'm explaining it here like this. If the equation of the circle is given to be x square plus y square plus 2gx plus 2fy plus c equal to 0, first convert it in the form x plus g whole square plus y plus f whole square is equal to g square plus f square minus c, that is equal to r square. Okay, because this is the same form as this. Okay, and then the equation of the tangent to the slope will be using the second category, that is y plus f is equal to m into x plus g plus minus g square plus f square minus c into square root of 1 plus m square. Okay, so this is the one, and this form, as you see, it is in the same form like this. Okay, so this is the way we need to derive the equation of the tangent in the slope form. Okay, if the general equation of the circle is given. Correct, dear students? Now the last point what I would like to mention is that what is the condition of tangency for the line y equal to mx plus c on the circle x square plus y square equal to r square. That means in simple term, if I give you that equation of the circle as x square plus y square equal to r square, and equation of a straight line. So suppose a equation of a circle is given something like this. Sorry. Equation of a circle is given as x square plus y square equal to r square. And what is the tangent? An equation of a line better than tangent, the appropriate word is the line. Y equal to mx plus c. Y equal to mx plus c is the equation of the line, and x square plus y square equal to r square is equal to the equation of the circle. Now that line can either be a tangent to the circle or not. If that line to be qualified to be the tangent to the circle, what is the condition has to be satisfied? Okay, the condition to be satisfied that the line y equal to mx plus c on the circle x square plus y square equal to r square is c square is equal to r square into 1 plus m square. So let me write it down, dear students, and you'll get it. Okay. So the condition of tangency for the line y equal to mx plus c on the circle x square plus y square equal to r square is c square is equal to r square into 1 plus m square. If this condition is satisfied, then we can say yes, the line y equal to mx plus c is a tangent to the circle x square plus y square equal to r square. With this note, dear students, I would like to conclude the class for today. In our next class, we will be discussing about the equation of normal and other relevant topics. Thank you very much, and we will have our next class tomorrow, same time.